Testing, testing. Testing, testing. All right, two people are in here. Last year I had hundreds. This year I have two. Well, you can start typing questions if you want at 7:05, so fair's fair. Start asking away anything you want me to go over, ask some questions. I have all the projects from the whole year here, stuff like that. So go for it. 3 whole people. Holy cow. Somebody give us a question here so we can get some stuff going. You got the whole chat room to yourself, right? Ask away. Haha, that's pretty funny. You got to be a little more specific than that. Well, I'll give you an idea. Last year when we did the stream, kids just asked questions. Like they may have asked, like, what's encapsulation? Sometimes they had a little problem, like, I don't get how recursion ends, things like that. It's just questions they had, right? And once people started asking questions, uh, just more and more questions started coming, right? And people started asking, and we just went for like an hour and a half, just showing sample projects where the stuff was in, etc., etc. Okay, I can go over a little bit of the definitions of encapsulation and abstraction. So, encapsulation has the word basically encapsulate in it, right? Which basically means to package up, put stuff inside. So, one of the examples I give the class here, let's see here. Let's see if this class actually has stuff in it. It might be a little empty. Okay, so this is an okay example. If you were going to write a program and your program was to represent summer school, grades, all the students, stored, you could just write this entire program inside of void main. You can make all your variables in here. You could have arrays, array lists, the data that keeps track of all the students' names and grades and age and all that stuff. when it comes time for a student, let's say to calculate their average grade or their GPA, you could code that all inside a void main, and it would probably work, and it would be considered really sloppy. So one of the ideas in object-oriented programming is encapsulation. Think of the behavior or the tasks your program has to do, and then consider sort of packaging it up, encapsulating it into objects. So one of the objects you might decide to make is you might decide to make a student. And so when I make the student class, I'm going to make the student class handle all the code that's related to a student. So I may have the constructor here, get name, set name, but of course you could add extra stuff like, get average, and, code it properly so it actually gets the average, and anything else, right? Print schedule. Good typing here. Print schedule, does its code and prints the schedule out. So this is what they basically consider encapsulating. The variables for a student are inside the student class, and all the methods that are sort of related to the behavior of the student are inside the student class. So that's encapsulation. For the actual person using the student class, they don't actually ever really have to go inside the student class and see what's going on. All the behavior is encapsulated, and what the person on the outside using a student gets to do, I'll just see if the school class here uses students, but you could have the school class, and maybe they make a student, right? So they make student A, and I forget how my student was made here, name and age, and then they can say, A dot, system out, print line, A dot, get average. Now, this is the idea. No, I don't know. Did I not spell it get average here? Double get average. What doesn't it like here? System out, print line, A dot, get average. Somebody tell me, type out what I've done wrong here. Anyways, pretend that line's not red right now. The idea of abstraction is the idea that you can just use it at this level. So the abstraction is a bit of a weird word, right? Because it has its meaning in English, meaning abstract. But in programming here, it basically means this. I've provided public methods to do tasks. Maybe the student class also had a private method in there, private void partly get average. And maybe this method is used inside of get average. But the programmer only has access to the public variable, get average. And so when you go to your school, when you hit class A here, let's erase this, go class A dot. Why is it not liking this? I'm just looking here if it's packages. Package summer school. This is a bad start here. Okay, this looks good. A dot. I'm going to rename my student temp in a desperate attempt here to get this working. Student temp is a new student, Bob, 15. What in the world? Name this public. Somebody type out space after out. Haha. Let's see here. Anyways, let's say I go get average when I'm just trying to calculate their average here. The idea of abstraction is it's what you have available to the viewer, what they get to see. So I don't care what's going on behind the scenes here. So when I use get average, I don't care what the method is doing, and then I don't care that it may be using some private methods inside. The abstraction layer is basically your public methods, okay, that you get to use. And so those are sort of the access to run the code in the class. That's the basic idea behind abstraction. You don't have to know all the fine details of how the class is working. You just have to know what has the designer of the class, given you access or allowed you to use. And so that's the idea of abstraction. So abstraction's the sort of what you see on the surface, so basically the method calls, okay, that you can use. And encapsulation is the idea that you put a bunch of behavior and variables inside a class to package that behavior up as one unit, right, that you can create. Bonus if you can tell me why this is still giving me. Oh, now that's working. Very odd. Okay, give me another question. Keep it going. Okay, static methods and normal methods. Let's see here. There's got to be one here. Static class examples. Okay, calculator. Okay, so there's two parts with the word static. Okay, when they do the static, a lot of students think it means what final does, right? Final means cannot change the value. It's a constant. So as soon as you put final in front of a variable name, if you try changing it later in the program, it's not going to let you change it. So if you see here, if I do something like this, if I say pi plus plus, it's going to underline it red, and the error is going to say cannot assign a value to the final variable. Okay, it's 3.1415, and it's final. Okay, so that's a constant. The word static for variables means that the variable is shared among all instances of the class. So this one's actually a better example. Let me switch to player because this is a good one. So this example takes a minute or two to go through, right? But it's a good example of how static can be used. The class player has a static variable called nextID. So if you make 50 players in a multiplayer game, all those players share this one variable called nextID. It's public and it's static. So the static doesn't mean it can't change. Static variables can change. Static means it's shared among the class. Now, one part about static variables means you can do stuff like this. Where's player? I can write a line like system out print line player dot last player created. Okay, so the last player created was also a static variable. Okay, maybe I should stick with nextID for this example. So one thing about static variables is you can access them directly through the name of the class. Okay, they're not owned by individual instances, and because they're not owned by individual instances, you're allowed to do this. Okay, so that's one thing. The next thing you get to do with this is if you do create a player, like down here, player 1, player 2, player 3, any of them have access to the variable. So player 1 can access my ID, player 2 can access, sorry, I'm doing the wrong one here. Player 1 dot nextID plus plus. This would make that nextID variable increase. And so what you're going to see here is this sample program's actually done an interesting little thing with the player and the nextID. There's two static variables here. One of them is called nextID, and then it works with the instance variable myID. So every player has their very own myID, right? That's just a regular variable. And so what happens when I create a player is the player sets its ID to the static variable that's owned by the class called nextID. Now when this all starts up and we run this program, nextID is set to 0 and it's shared, right? It's static. Its ID gets set to 0 and then it can say, hey, nextID, go up by 1. So now the shared variable is up to 1. The very next player that's made, so like in Game Runner when I go and create player 2 runs their constructor and it comes in here and it sets its ID to the nextID variable, okay, which was 1. And then it ups it by another. So you can see here, it's an interesting relation. The way it's being used here is that every single player that gets made accesses the class's static variable to find out what ID it should be assigned. So it's almost like a little bit of a loose connection between all the instances you've made of a class. So this is one thing you can do with it. Another thing you can do with it is exactly stuff like this. You can make a static variable like pi, which makes it really convenient inside a runner to do stuff like, where's the calculator here? So if we ever want to know pi, you can just do this. Hey, calculator class, tell me what pi is. Okay. Another good one, let's say this calculator program was going to be doing something with a lot of taxes. You could write something like this: public static final double tax rate is 0.07. Let's say you were going to make tons of bank accounts and you have to do a lot of work with bank accounts. Rather than give every single bank account its own unique tax rate, if you know the tax rate is going to be something that's very constant, the same for every single bank account in the program, then you can make that a static variable, and then they all share the one variable. So if you have a million bank accounts, you don't have a million individual variables floating around, you just have that one variable floating around. So you don't just use it whenever, you use it when you sort of have a purpose for using it, right? Whenever you can use it for this rate or for this purpose, like the tax rate, that's a good use for it, right? Because you're saving on memory, and if it's true that all the accounts will always share the same tax rate, then that's a good use for that variable and using static in that case. Now, static methods have a slightly different thing. They can still be used the exact same way. They can be directly accessed. So I'll just power. You can directly say, hey, calculator class, use your power method, right? And you give it the arguments it needs. So that's a static method. But to be able to make your method static, there's one rule. It can't use any non-static variables. So for instance, if in here I had a variable called, I don't know, integer factor, and I put 10, okay, whatever this is going to be, this is not static. So the only way you get one of these variables, right, this is an instance variable. You have to make a calculator in order to get an instance variable. Because these methods can possibly be used directly from the class, it's possible you're not making an instance a calculator. So a static method can't use an instance variable. So if I said it's like factor plus plus, you're going to get the line saying, no, you can't do that. You've said that this method is static, and you're using a variable that only exists when you create an instance of the calculator class. And so that's your rule with static methods. Now, you should make methods static when you can. So if it's an option to make a method static, make it static. It tells the person reading your code that the method does not rely on instance variables. It might use these, right? So you can use static variables for sure. So I could say pi is final. I could say integer x equals pi plus 5. Oh, come on. Oh, possible loss of precision. So you can do something like that. So you can use static variables in static methods, but you cannot use instance variables in static methods. And that's really the idea with static. So with variables, it has to do with shared, and with methods, it has to do with you're not using instance variables in the code. That's a little bit of a summary. I see someone ask there, so what does static really do? I mean, in the most basic, it basically makes one copy of the variable or one copy of the method in the Java virtual machine, and all instances get to share that method or that variable. I mean, that's the core basics of it. And so I see one of the previous questions was, what's the difference between a static method and a normal method? So I think we sort of went over the basics there, right? Static method cannot use instance variables. Let's see here. What's a brutal exam question? You guys can look in the review questions and decide for yourself. Everybody's going to have their different answer for the worst question. But definitely every 2-3 years, there's an AP written question that even I look at, and I got to reread it for 5-10 minutes, and I shouldn't have to do that after doing it for so many years. And then all the students come back and say, I didn't even understand what to do. Hopefully that doesn't happen to you. The best advice there, don't give up on a question. I mean, the test is the test. There's 4 big written questions at the end, right, in the written. You just got to keep reading, relax about it, and I guess do your best, right? If you don't understand a question, put some code down, right? You get marks for doing anything. You can pick up a few extra marks. What does compareTo do? This is typically every year a bit of a weak one. compareTo, let's see if I have a comparable somewhere down here. compareTo. Maybe it's in the strings class here. No. I don't know why there's not a compareTo in here. Comparable. Basically, if you want to know what compareTo does, compareTo is a very simple method. Its signature is public integer compareTo. The basic one is object O, and its job, it returns a number, right? Well, it obviously returns a number. It returns an int. And what you're supposed to do is usually it's used in comparing the object that's calling compareTo. So let's say down here you had like a student, right? And you say, hey, Bob dot compareTo some student named Jen. And since this method returns an integer, it's always used like this. It's always used Bob dot compareTo Jen bigger than 0. Bob. This would happen when Bob is bigger than Jen. Now, this is the calling instance. Bob, let's say Bob's a student, would have coded compareTo. And the argument is Jen, so that's the object O. If you're actually coding this for student, you'd probably do this. You'd go student S. And let's say students had age, and you wanted to compare them on age. Probably the most basic code for this would be this.age minus s.age. Okay, now students often ask, well, aren't I supposed to return +1, 0, or -1? And the answer is you can, but that's not how the method is intended. Notice down here, when you use compareTo, you're not saying ever, and when you read sample code, you're never saying if Bob.compareTo Jen is 1. You're always saying if Bob.compareTo Jen is positive, right? Bigger than 0. So rather than complicate this with +1s and -1s, you're always going to see coders usually code it like this. So let's say Bob, who would be this, right? Because he's the one calling the method. If he's 20 and Jen is 15, then it's going to be 20 minus 15, which is 5. 5 is a positive number. So Bob compared to Jen sends back 5. If 5 is bigger than 0, yep, then that means the calling instance Bob was bigger. If you flip those numbers around and make Bob 1 and Jen is still 15, it's going to be 1 minus 15 is -14. It'll be less than 0. Okay, so this is basically what you see done in compareTo for the most basic examples, and especially for the AP exam. They want you to know it at this level. Sometimes I've seen one of the AP questions, they get you to do compareTo based on 2 variables. And so you have to decide, they gave you the conditions and you got to decide, do you want to send something back? You do not have to send back 1. You could send back +5. You can send back the difference between 2 variables, right? But that's the basic idea between compareTo. Somebody quickly asked, do I ever use Eclipse? Is it better? People argue that one. I mean, seriously, the only way you're going to know is by using them. Eclipse is more widely used. NetBeans is way back when I started teaching C++ and Java at my school. Eclipse didn't have the plugin for GUI development, and I wanted my kids to be able to do frames and buttons and scroll bars and sliders and stuff, and NetBeans had it just built in automatically with the install. So I put NetBeans on the computer, and then our school district is a bit of a pain in the butt to get software installed, so I just left it on there, and that was like 20 years ago. So I've just used NetBeans the whole time. At this level, the way you're coding, in computer science AP, honestly, you're not going to notice a difference. You type your code, it underlines stuff, it runs it, it does the same thing. Professional-wise, it's really what the company's using, right, is what you're going to use. The double equal sign. Yes, the double equal sign is for comparing equals. So if you do this on the exam, if you say if x equals 5, if you say if x equals 5, print out high, this will always print out high. Okay? This basically assigns the value of 5 to x, and it actually returns true, success. So this is actually always saying if true, okay, because it's a statement, and then it'll always print out high. So yeah, you always want to have the equal sign, and that does matter on the AP exam because they are two different commands. The equal sign is basically a method, right, that's doing something for you, and the single equal sign is basically a method too that's doing something for you. So yeah, you got to use the right one. Why would you use an interface or an abstract class? Oh, we just did this one in our class. Okay, here's a bit of an example here. The best example, like a big picture one that shows you why you might use an interface, is this remote control car example. So my students will be bored here, but I'll go over it just quickly. So what I want to do is if you were trying to set up the world to have satellites that were going to remote control cars, and you want one satellite to control every single car in the world, and all the car manufacturers agree this is going to be the best way to go about it, right? One control system. What do the car makers have to do? Well, they all sit down, they talk with the satellite maker, and they say, here's what we need the satellite to be able to do with our cars. The satellite maker says, I'm going to make an interface called remote controllable. I'm going to put get position, get speed, get direction, set target speed, set target direction. And I know a real car would have way more methods, but just go with this. These are the methods and that the satellite needs to use on your car. So they make this interface called remote controllable. If your car can code all these, you get to be considered a remote controllable, right? So Ford, they do their car software. They got class Ford car, implements remote controllable. Hold on here. Okay, they code all the methods that are required to satisfy the interface, right? So now they can write implements remote controllable. Of course, they have other methods to make their car work. I mean, to get direction, there's probably other ones here that have to access their GPS and stuff. To set target speed, they have to change the gears and RPMs and stuff like that. So they have tons of other code, but they satisfy that interface. Honda does the same thing. They code all their stuff the same, or sorry, different ways, but guaranteed they satisfy the interface if they want to participate in the satellite program. Okay, all the car manufacturers do this. Now here's what the satellite can now do. So here's our Jarvis car manager. It might have an array list of remote controllable. These are all the cars it can control that are out there in the world. Now, by declaring this a list of remote controllables, you can only be added to this list if you implement remote controllable. Okay, it's a guarantee. By guarantee the remote controllables, it means that all the methods in the list, so as a satellite tries to take control of cars and do things, it can now do anything. Whoops, I just used set target speed. It can use anything that's in that interface. It knows it's going to have those methods. So now the satellite system writes its code to control the cars using only these methods from the remote controllable interface when talking or dealing with the cars or trying to control them. Of course, it can have its own methods too, but when dealing with the cars, it can only do what's in remote controllable, and all those cars are guaranteed to be remote controllable because that's sort of what they signed up for. Yeah, we want to be part of the system. You better implement remote controllable. Now, where else do you see this? You see this in things like the remote control fridges and ovens and house heaters. It's just a general idea. Printers, software, when you want things, to follow a certain structure. The other big example in the course is like various lists. So you'll see here in list worker, when you declare lists, don't do a array list of strings. It's better at the top of your program to make it general, the list interface of strings. And that way on this side, you could do a linked list, you could do array list, you could do vector list, or is it just vector? You can do any type of list you want. The code from that point down doesn't have to change at all, but when it actually goes to do something like remove, well, if it's a vector, it's going to remove it with the vector class's code. If up here you had made your thing in memory a array list, it's going to use the remove command from array list, right? Different lists might have different benefits. So it's a very general way. This even allows it that if you think you're some genius and you come up with some totally new list out there, then what you can do is you can write your own list, make it implement list, right? Do all the methods in the list interface. Now you could qualify there. So if your name was Bob, maybe you make Bob list. And now anybody's software could just replace Bob list. And the rest of the software works perfectly because it was always just referring to a list interface item, right? And your Bob list will have all those methods, so everything works nicely. So, I mean, it's a bit of a big topic to cover in this one, right? But those are some of the basics. For the exam, you do not have to know anything about GUI. The exam won't even have you printing stuff out. If on the exam they get you to print stuff out, hold on here. If on the exam they get you to print stuff out, they'll actually tell you the method, like this method print stuff out. You don't even do system.out on the exam solutions. So if you've gone through a bunch of those practice written questions, you will know that. Just go look at all their solutions, right? There's never any system outs. Everything is always write a method, write a class, modify the method. Fairly straightforward as long as you understand the question. No applets, no HTML. That's not on the exam. Like I said, if you're still wondering about what kind of questions can they ask you on the exam, if you actually just go to the website, here, hold on here. I don't know if you're from my class or just internet stranger, but if you go to atomictoddler.com and just go into, actually type test prep. This folder here has like 15 years of the writtens and the solutions and some practice exams and a whole bunch of other stuff in there. You go through that, even if you just scan it, you won't have to ask how many questions of different types are there. It'll be very obvious. You'll know exactly what they're going to ask you, right? You just got to go through the exam and check. What else here? Yeah, let's see. I'm not going to do a senior CCC question on the stream, though those are mostly all recursion. And it's recursion like at a level that's definitely higher than anything you'll have to read on the computer science exam. Can the final project be worth 100% in term 3? Yeah, right. All right, keep asking some stuff. I may or may not have another stream before the exam. Maybe the night before, I come on for like an hour just for some little last minute questions. Somebody asked a little earlier, why use an abstract class? Um, Using the abstract class is definitely it's a hard one for students to understand. Like they all memorize the rules, right? Like what an abstract class is, but the why they use it is a little trickier because we never really write projects that large because we're sort of rushed for time in the course, right? Like we're doing it in 8 months when most people do this in 2 years or 2 school year courses. Um, Regular student. So here's a little example of why you might want to do a abstract class. An abstract class is useful when you know the structure of your project, you've planned it out, right? And you know that certain classes are going to be related, yet have some difference in their function, the way they run some methods, or some might have some extra methods. So like this example here, we have student class made abstract. In the project above, I just made it student class. So in this one, I made it abstract. And the reason I made it abstract was just to sort of force some points here. So I'm going to have two different types of students. I'm going to have a regular student, and I'm going to have an exchange student. And I know right off the bat that a regular student and exchange student, the way their marks are calculated, they're calculated different, right? Let's say the English mark isn't used in the exchange student. So you'll see here, I've purposely left get mark and get average mark as abstract methods. These are going to be different. And just to add another, I put talk, right? So these are three methods that I know I want every student, they have to have, but I already know because I've thought about my project before I start coding it, that the regular student and the exchange student are going to do these three things differently. So then what I do is I go through the rest of the abstract class. I code the stuff that they do the same, like get age, set age, get address, all these ones here. Other ones not shown that they probably do exactly the same. And then when I build the regular student, I build it off of student. So I extend student, and then I go and code those abstract methods the way they work for a student. And then I do the same thing in exchange student. I build exchange student off a student, and then I code the abstract methods the way they're done, and they're done a little bit differently the way they are for the exchange student. So this one really requires that you sort of know your project, multiple classes, classes that build upon other classes, like that. And so that's the idea of abstract, right? Is you can even have the abstract class that has nothing coded if you wanted, but if you had a class that had nothing coded, you'd probably be making it an interface instead. How much do you need to know about searching and sorting? Okay, so for searching and sorting, if I had to put a priority, and of course, yeah, this is like gambling, and you're not supposed to gamble. Hold on here. Let me find my streaming. Hate those things. If you were to put searching and sorting, like you're crunched in time and you want to know what to do, definitely no linear search, right? Just basically going through an array straight through in a line. Do no binary search. That one's not that bad, right? Know the idea. So if you read the code, right, they're not going to ask you to code the code, but if they gave you code and they left out a line and said which line is the proper line to put here and here, you should know it well enough to know which lines are the right lines, right, to make it work. And for these two, you should know about sort of the efficiency, right? Like binary search, how many times would this line run, right? So you should be able to look at the routine and know what it's doing, right? Like if you have 1,000,000 items, you should know it's going to do about 1920, cut in halves. For linear search and the numbers at the very end, well, if it's 1,000,000 items, you're doing almost 1,000,000, questions to ask, right? If on average, linear is going to be half the size of the list, binaries, keep dividing by 2, right? For your other searches, bubble sort isn't even part of the course. Even though everybody teaches it, it's not part of the course. Sometimes they ask a little bit about selection or insertion, but honestly, I'm trying to think of times when they've asked you to code it or even really ask too much about it. Not really. Maybe they say a student's code this, What can you say about the code? And it should stand out as selection sort. And then if you know it's selection sort because you know it, then you have an easier time answering the question. Somebody that didn't know its selection sort probably can still read the code, but they're not going to be as fast at going, oh, that's selection sort. It's finding the smallest and moving it, right? So those would be the two, you know, for the searches I would do. For the sorts, honestly, they've only asked about merge sort like I think like once every 5 years or something. It's definitely not one I would spend time on if you have other problem issues in the course. Um, are there labs you need to know for the exam? No. That every teacher just does different activities now. Up to 2 years ago, for like 25 years, we all did the exact same giant lab that we spent like a month or two on, and then they would ask questions about that lab. Uh, Too many teachers complain that the kids found the lab boring and they wanted to do better stuff or whatnot. So no, there's just basically no lab questions. If you were to the university course, how long would it take to go through everything we did in AP Computer Science? Okay, so like at my high school, computer science, we run it just from September till basically March, right? We do the 7 months. We do from knowing nothing to AP exam in the 7 months. Uh, that course at UBC, so we did about 60 hours or 60 classes, right, before the exam. So that's about 60 hours at university. That would be one term. So that would be September, October, November. But keep in mind, you would have 3-hour lectures a week for 12 weeks. So that's 36 hours of instruction, like lecture time. But then you'd also have another 3 hours a week of lab time. So you'd have another 36 hours of lab time. So it sort of adds up to roughly about the same amount of time um, that's used. But just in university, you have 6 hours a week to work on the course. In high school, you have 3 hours a week to work on the course. De Morgan's Law. De Morgan's Law, really quickly on that one. The AP exam does ask this almost every single year. There's at least one question on it. It's also a nice one for you to know just as a programmer, but it basically means this. If you're asking a Boolean test like if A and not B, basically it means the rule is, and it's easier to explain with a whiteboard to draw, but it basically means you can also do this. If you know your math, and I always call it factoring out. If you were to factor out the not symbol, that would leave you with not A. Let's see here. And it would leave you with B. And so the sort of reasoning here is not times not cancels out, leaves you with A. Not factored onto B leaves you with not B. But in order to do this factoring thing, you must change any and symbol to an or symbol. So those are basically equivalent Boolean conditions. If you do your little chart here and you said, when A is true and B is true, and then you went through and said when A is true and B is false, and A is false and B is true, then A is false and B is false, and that's the long way. If you went and tested the 4 possible values for A and B in both of these, you're going to get the exact same results every time out of your code. So a classic example of this is sometimes in, let's say, a password loop, the while condition may say repeat while, and it may say while, let's say the password is A and 1. So you'll say, well, name dot equals A and password dot equals 1. So let's say that's the good condition. So you may say while not name equals A, or not password equals 1. I think I have a mess up there. You have to repeat, and they have to enter the name and password again. So that's one way to write the condition. But the other way to write the condition if you know De Morgan's, is, I'm having a right-click stall out here. The other way to write this condition is you could have maybe said not name equals A. Come on. And password dot equals 1. And so you'll notice I factored out the not symbol, but I changed the or to and to or. And so that's really all the basics of De Morgan's is. So you can look at these Boolean conditions. And like I said, almost every year there's one of those on the multiple choice. So it's almost a guaranteed 2.5% on the exam if you know how to do that real quickly. If you don't know how to do it quickly, you literally just got to make your table and run it through as fast as you can, writing down whether they're equivalent or not. Let's see here. The computer science B course, they don't run it anymore now. The B course used to have topics like, it all had to do a lot with nodes. So the idea that one object points in memory to the next object that holds a value. So you can link them. So the very first topic was linked lists, and then doubly linked lists, and then you studied ways to store data. So if objects can point in memory to the next object in a list, then you learn about trees and et cetera, and heap sorts. It had a bunch of topics, and they were all very related to the same idea about memory addresses linking to the next value or object, in a line or a collection of objects, right, representing a list, and all the ways you can sort, organize, etc., and the analysis. So a lot of students found it pretty tricky. It was sort of like the next level up. If you are going to study computer science, you're thinking about going into computer programming, you know enough to explain or explore these topics on your own. You should just start with something like, what is a linked list? And go see if you can learn it on your own online. I never want to give total ultimatums, but if you have trouble learning about linked lists by yourself, like through a good video or two, I'll give a few videos, but if you really can't get it and it really starts to confuse you, that's the direction a lot of the computer science ideas start to take. Or it's sort of that little jump in level between computer science A and what the B course used to be. So the B course would be, if you went to university, it'd be like the topics you did from January to April at most schools. But like I said, computer science B, they don't even offer it. They only had about 15,000 people take it every year. At my school, which is pretty academic, I'd have maybe like 5 to 10 students out of 60 choose to do it. And then by the time the exam came, maybe only 5 would decide they actually wanted to write the B portion of the exam. The others that were good students had trouble learning it on their own. Okay, which is fair enough. Some of the routines are, they start to take it up a notch. If you read computer science A and B, would that basically be the first year of university CS? You know, I've been out of university now for like a long time. Um, I still talk to a lot of students that come back. Some say what we did in computer science AP was exactly what they did the entire year. Some said what we did took them up till January, February, and then the rest of the months they did learn about the stuff like the linked lists, or their teacher did database. Different teachers, different schools, they may sort of value something different, project based. So you really got to look at the school. Just go read their course guide and go, what course would you got to take? It'll tell you what 2 courses or 3 courses you're going to take, and just go look at the course description and see the topics, right? That's really the only way to know. They're changing it quite a bit at schools, right? Trying to make more projects and less of the theory in the first year. Universities, you got a big mix. You get a lot teaching Java. You have a lot teaching Python. I'm sure there's others doing different languages, but Python's popular because it's a little bit easier entry point. But in the end, the skills, I mean, if you're supposed to code a program that sorts students and finds the one with the best average and then find them a grad date that has an average within the same 5 points, you're doing the exact same thinking. True, the syntax is a little different. Curly braces versus no curly braces. Python, you must indent the code that matters. Java, you don't have to indent the code. What your brain is going to be doing to figure out the problem is honestly no different. Do not worry about the language. Every programmer is going to tell you the same thing. It's not about the language. Good languages, I think. C++, if you can handle it. Little harder than Java, only a little bit harder. Honestly, only a little bit harder, a few extra things. But if you're doing totally good with Java, you're not going to have trouble learning C++. And if you know C++ and Java, really, once you know one language, all the other languages fall in line very easy because you know the logic, you know the ideas, you know about methods and loops and iteration, and you know how to check your code and test and debug and stuff. It's all the same but different. So language, I wouldn't worry about it. C++ more for software engineering? No. I think a general answer is C++ would be more for programs where you want to have faster execution of the code. Like maybe tons and tons and tons of calculations and you want the programs to run a little faster. C++ is also more widely used, in industry. Java's also, you go look at jobs, there's still tons of Java jobs too, and Java's out there. Um, C++, Java's running through the Java virtual machine. It's like another step you got to go through. C++ will generate its code to directly run on the machine. So it's faster, right, overall. Although people do tests with a lot of programs that work with data, that's not super intense, and you compare the times nowadays with processors, and really there's not too much difference. So, go look on Quora. Go ask. I don't know if you know that website, Quora. Programmers there or Stack Overflow. What's better about C++? You'll get the professionals, their big lists of answers there. Okay, for strings, when might you use um, equals equals? Honestly, in your code, you will almost never use equals equals with the strings. So, strings are a little special. So when you go, string S1 is high, and then you go string S2 is high, and then I go if S1 equals S2, what you're asking there is you're not asking directly are the contents the same. You're asking is that, remember these are memory addresses, right? String is an object. So string is an object, which means the variable S1 is a reference variable. It refers to a spot in memory. The funny thing with strings is when you do this, you don't use the new word. If you make a string that's exactly equal to another string, S2 will actually point to the same spot in memory. So instead of you seeing floating around in the memory of the computer two individual highs, right now you're actually only going to see one high. S1 points to it and S2 points to it. So this is going to print out. So it's going to go in here and it's going to do this code, okay, because they print to the same spot. But if you were to make it with new string high, the new word sort of eliminates that feature of Java, and this absolutely makes a new object in memory. You'll have high somewhere in memory, and S1 basically gets you, refers to that memory address, and S2 will refer to a different spot in memory where that new string was made. So this will not happen. Okay, you're not going to get in here in this case. So that's basically it. When you use dot equals Dot equals, that's always checking. That's regardless. It doesn't care about the memory address. Dot equals is going letter by letter and checking are the strings equal. So when your purpose is for comparing the equal sign, comparing the equal sign, when your purpose is checking are S1 and S2 holding the same string, always use equals. I can't even think of an example of any AP exam that ever got you to do this, okay, where you'd have to do that. Now, could they put this in a question on the AP exam? Yeah, they could. They could throw that in there and go, a student has written code, but it's not functioning as expected. Why not? And then they ask you a couple multiple choice questions, and one of them might be, on line 14, the programmer isn't checking for a quality product. They're going to ask something about it, right? But that's a general idea. Okay. This idea here, by the way, when you just make strings with this, that was called the string literal pool. So when you make strings like this, every time you make the string, it checks to see if that string is already existing in the string literal pool. If it is, it just makes S2 point to the same spot as S1. Okay, so they are equal. For comparing integers, we already did that one. Definitely comparing integers. You have to use equals, okay? All right, throw something out there. We got the lull here. Yes, you can run Java programs on Raspberry Pi. So for those of you in my class that are doing your sensor project, our sensors have to be connected to the computer. And so basically you can't walk around with your project unless you're walking around with your laptop. But you could, if you have a Raspberry Pi and you just put our fidgets library on there, you can basically, and the Java virtual machine on your Raspberry Pi, then you can basically run your project anywhere. So if you're making like a temperature light sensor program, as long as you have it to a battery that's going to power the thing, you could go stick it in a tree and let your program collect data and analyze the data and stuff. Yeah. Raspberry Pi is basically a computer, right? So almost everything you can do on your Windows or your PC, you can do on your Raspberry Pi. It's just a computer that's back a couple years, right? A little more lightweight. Yeah, you can do wireless with the Raspberry Pi, but you're going to have to just learn how to do wireless. It's just network communication. And because Java and all these languages, it's obviously a common thing. All it really involves is you just import a library or two or three or four, and you just create objects like a network port connection object. You create it. And then that object, you tell it the IP in this, and then you ask it to use its connect method. A lot of the code is written for you already, and you use the methods that are already connected. Are you going to have to learn? Yeah, I would think to get your Raspberry Pi sending data wirelessly over the network to your computer, probably you're looking at, if you're at your level, probably looking at, with a good tutorial, uh, 1 hour would be super lucky because things always go wrong. But you're probably looking at like 2, 3 to 5 hours. But then once you get it working, you got it working. And the next project you want to try it with, you just grab the code and copy paste, right? So it's a good project. If you have a Raspberry Pi, it's a great project for your final project, just to do something like that. Yeah, on the AP exams, those little letters and numbers are basically talking about what section of the course they're addressing. So I don't know if I have it available here. I'm hunting my AP course. I'm looking for the course description here. Documents. Yeah. Anyway, the short version answer there is yeah, that's it. So if you go to the AP Computer Science, the College Board website, and you just download their course description, you'll see they have like section A1 is students will create and debug a program. Yeah, so it's just their way of categorizing the questions. What happens when you try to print an array or 2D array? Okay. Do 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 do. So an array is considered an object. Okay. So R is a reference variable. So nums are. So nums is a reference variable. It refers to a memory address or gets you to a memory address. And so when you print it out, system.out.println nums. Let's see here. This looks okay. It should just print out a little memory address thing here at the bottom. Where is it? There it is on the side here. So you'll see here it just prints out the reference. Now, I always tell my students this is a memory address, like where it is in memory. It's actually more of a handle. The Java virtual machine, right? It's keeping track of where stuff is. This is actually more of a link to the location in the stack of the virtual machine, and that gets you to the actual thing in memory. But same idea. So you're basically just getting a reference, right, to the object. Same thing with 2D arrays. If we were going to talk about 2D arrays a little bit, really main highlight, because, it's a big topic. Either coded them or you haven't coded them yet, in the course. But the biggest 2 points here is this. Whether this is column row or row column or XY or YX, it's irrelevant. All you have to know here, it's an array of an array, right? So it all depends what you do in the code. Like if I want 5 to be my rows, then everywhere in my program, just remember that your first dimension is rows and the second dimension is columns. And vice versa, right? You decide. Remember, in memory, it's not laying this out in a neat little tic-tac-toe grid. It's memory. Who knows? It does whatever it does. Who cares? But you control what these dimensions are. A common one, though, may be to know how to get the 5 and the 15. So when I do something like this, system println nums.length. Okay, what's length going to print out? Is it going to print out the 5, or is length addressing the 15? Now, this isn't told to you on the AP exam, right? You're supposed to go in knowing this part. So you can take your guess right now, and by the time I run it, hopefully you just know off the top of your head. And when you do that, you get the 5. So you get the first one, and that's the easiest way to remember this. Okay, if you just say, hey, dot length, then it goes for the first number. So it just goes for the 5. The 5 is the first number. Versus you go for something like this. Hey, num slot 0, what's your length? Now, the easiest way to remember this one is you're basically going into slot 0, then asking, what's your length? So this one's going to get you the 15. And we'll just watch that one print out. And so that's one little thing you probably should memorize, right, or know how to use that one. So you'll see that if you have to write for loops or loops, where they give you a matrix and they haven't told you the size, which is very typical. Just you're getting a matrix, you don't know the size. If you don't know the difference between those two, you're going to do a 50-50 guess, and why lose the mark, right? Memorize that one. Could we discuss 2D arrays more? That's a tough one. That's a big topic, right? I mean, if you know how to use arrays, you know how to use 2D arrays. Typically, you just have to be organized, right? Like the problems are always going to be the same thing. It's usually going to be a row column or an XY, depending which one you want to do first. Like if I say that this is the row, and let's do opposite. Usually it's column, row. And the reason it's usually that is you usually have X, Y, right? X is columns, Y is row. But that's no guarantee, right? So if we were doing it this way and I wanted to print like a book, print the matrix out, I want to go through every row, and for every row, I want to go through every column. So I would be doing, r less than nums dot length. R plus plus for integer column is 0, column less than nums. Whoa. And then whatever you're going to do, right? That's your typical starting point for the matrices. I'm trying to see here if there's a warning. No, that's basically it. The big problems they do with arrays and matrices sometimes is the boundary conditions. Just be careful. I'm starting at 0, and I'm going right to the last index position, right? These are your standard lines you've been using all year. The one thing you have to be careful here is if somewhere in your code you're doing something like this, I don't know, numc equals numc minus 1, there you got to be careful, right? The c minus 1, as soon as you do anything like that inside your array or your matrix code, you better go check that you're not going to break an out of bounds error on your boundary limits, right? At the very start or the very end. So since I'm minusing 1, that doesn't make 0 a very good starting point, right? I'd at least have to make it 1 for this to work. And so really that's, just I guess maybe the tricky stuff that you may have to look out for on the exam. Boundary conditions, right? Just don't be happy with a value dead in the middle, right? Test the beginning, the end, and a number in the middle. Why do we use dot equals to compare objects? Okay, it's basically the same answer. I haven't actually done this one with my class. It's a good question. I don't think I've ever seen that pop up on the AP because I could be wrong. I don't think I've ever seen that pop up, but it's the same thing, right? Like if you have student A, who's a student, and you have student B, let's say this is Adam and this guy's Ben. Right now they occupy 2 different spots in memory, right? So if you're going to do an if statement and you said if A equals B, the answer is no. They're 2 different objects in memory. But if on the line above you did something like this, A equals B, you basically say, hey, A, set yourself to refer to the same spot in memory as reference variable B. Now B points to Ben and A points to Ben. A equals B is going to be true. Okay, so the equal sign again is doing the reference variable, whether they're equal, not whether the values in the objects are equal. Obviously, if the objects are equal, they're equal. They're pointing to the same guy. The content will be equal. But let's say you had student A and student B, and let's say it's Adam. He's 15, 99% average. And student B is also named Adam, and he's also 15, and he's 19. These two, right, if they were created with the new word, right, so you made them both new students, right, and filled them up properly, these two students have different spots in memory. So if you ask this, if A equals B, the answer is no. They're different spots in memory. But if you asked if A, what did you do? Oh, if A dot equals, and remember you could do compareTo as well. A proper class would probably have compareTo coded. But if you go if A equals B, if the class is coded the equals method, and it's sort of like compareTo, they're going to code it to check equals, then the answer is going to be yes. They are equal objects. So it's usually a method that's put in a class to let you check if the properties of all the variables, right, or the values of all the variables and stuff are the same for both objects. So that's the dot equals. But like I said, dot equals and dot compareTo are they're similar, right? Dot equals is obviously narrower. compareTo lets you do bigger, smaller, or equal. Oh, the AP exam. Oh, so Paul's in the online course. The AP exam doesn't count towards your grade at all. The AP exam is absolutely purely supposed to be the experience of what one of your university tests may be like, because a lot of them are 2 and 3 hours long. Um, it's also a to prove by the college board and the universities if you want to try to get credit for the course, they don't want to trust a high school teacher that maybe like their first year teaching computer science and they feel bad that they did a bad job, so they give all their students 100%. The universities don't want to trust the teachers saying, don't worry, this student is qualified, you should give them credit. So they make you take the AP exam and pay the money, and then they will determine whether or not you get the credit. Now, that being said, there is a final exam in the online course, and it's very similar to the AP exam, except I don't put the super tough questions that I look at and go, yeah, that's a little unfair, or that's a little too hard for this level, like they're just high school. So it's an easier version of the AP exam for the online course, and the same for my course. I'm sure you would have done fine anyways. Yeah, people, you have to remember this one little hint of advice here about the AP exam that the students seem to forget. You can't get depressed on exam day if you're going through and you have trouble answering some questions, okay? It is around, I think it was 72%. 72% got you a 5 on the exam, I think, in the last year or two. Around 63% got you a 4. And so you can understand here, you can go through the multiple choice questions and you can literally get every fourth question wrong, right? And if you're just going for the 4, which still gets you the university credit, I think, at every university, then you can literally get, I mean, it's not quite half, but look at that. That's like every third question you can get wrong and you still score well. All they want to do on this AP exam is know if you took this course at university, would you have passed with 50%? 5 means for sure you would have passed. 4, yeah, a good chance you'd pass. And even a 3 at a lot of universities ago, that's good enough. And I think a 3 is like you need 50%. So, you know, if you're worried about getting the credit, like getting the 4 or the 5, getting a 5, only about what, like 23% of students get this. In my class last year, I think I had about 50% of my students, 50, 60 got a 5, and a lot of the rest got 4s. But I think the breakdown on the AP site, they'll tell you, is something like that. You know, about 45% of the students, close to 50, get a 4 or 5. right? So, if you're well prepared, you've been coding everything you're supposed to code, and you're not copying code, and you know the rules and polymorphism and inheritance, it shouldn't be that bad to get your 4 or 5. Specific methods that you should know for the free response. Sure. Definitely, like absolutely, absolutely. No linear or a sequential search, right? Know how to search an array, a matrice, or an array list, or just list in general, right? Know how to do arrays and array lists, and which, by the way, do not make the mistake, you know, that's an array. Arrays have square brackets. Array lists are just lists in general. Use methods, get, set, remove, right? Do not put all square brackets when using with array lists. An easy way to lose marks, right? So simple, right? Just keep that one. Don't make the mistake, because I do get your written responses back later in the summer, and I get to look over, what people did. And every year, there's students that obviously in the stress of the exam, I guess, they make that mistake, right? And they lose a couple easy marks. So linear sequential search, you use it in so many problems. The other routine that I see pop up a lot is the idea of going through a string, like let's say A B C, A B C, A B C, A B C. And the questions aren't necessarily this question, but they're like this question. Say, write the method that would remove the first ABC out of the string. So, students will do some sort of, they'll use the string, right? They'll go like, integer position equals s dot index of ABC. So they find out where it is, and then they remove it, using substrings. Then the next part of the problem says, using the method you just wrote, remove all the ABCs, right? And sometimes what you see students do there is you see them rewrite all the code, but now on the recent exams, it'll say for full marks, use the method you just made, right? And so you should be able to set a do while loop up that uses this method that you wrote. Can you write the short do while loop that'll keep doing it, right, until there's no more ABCs? And it would do something like this, right? It would be like while the string index of ABC. So while it's found, right, you're looking for ABC in the string. If it gives you back a number bigger than 0, you know there's 1 in there, then remove first ABC, right? That might be the method, right? Remove the first ABC and S. And this while loop just keeps going until there's no more ABCs left, right? It's a very common theme, right? Like this little routine, I don't want to say it's an algorithm, but it sort of is. I see students writing for loops inside of for loops, doing so much work. When you're working with strings, if you're ever writing a for loop to search for something, you're wasting time. That's the whole reason the class has the index of method. Like if you don't know how to use index of and you're writing the for loop that searches, remember you could just search for A, or you can search for big strings, and most importantly, I'm not sure if it's the number goes first, you can search from a position, right? So if I want to start searching from here. So this one's, definitely almost every year you get a string question that's going to use index of and a repeating loop. Like keep doing the thing to clear out a string or modify a string, right? I don't know. Just a guess for this year. Who knows? Other popular routines you should know. So linear search, absolutely. Other little routines. I'm trying to think here. Obviously, the core basics in arrays, like max, min, average, right? Those ones are obviously easy to throw into a problem, right? Sum, right? Those are core. Yeah, I mean, you should be able to code those, as fast as you can handwrite or type, right? I can't really think of any other algorithms you really have to know. If you go through the course description, just download it from the AP site there. It's an easy find. If you get the course description, look through it. It'll list the things like you should be able to traverse an array, which basically means go through an array printing every item or summing every item. You should be able to find the max. You should be able to remove an item. Oh, I guess that's another one you should be able to do. It doesn't pop up super often, but do know how to remove from an array. So basically, the resizing of an array, I wouldn't put it at a super high priority if you have other things you're trying to learn, but you should know how to basically make a new array that's smaller, copy everything over, and re-reference the array, right? So in effect, you've made your variable point to a smaller array. You should know how to do that. And of course, you should array list, that's easy to do, right? You just use remove. I'm looking at Terry Kim's last question there. If we use a for each loop, we wouldn't need to use the bracket. Right. Yeah, if you haven't seen the for each loop, let's say you're going through students, an array list of students for student temp, and let's say my array list was called students. Yeah, basically you can just, this basically says, hey, go through the students array list, right? And this can be any list or array. It's actually could be anything that falls actually under something called the collections. We don't do it in the course, but all collections, you can use the for each loop. Lists count, arrays count. And so it says go through the entire list, pull it out, call it temp, which is a reference to a student. Yeah, and then you can do whatever you want, like temp.grade++. The only thing you can't do in the for each loop is don't try to remove the student, right? Or insert a new student. Once you have this process starting, it uses something called an iterator. Once it's kicked in and going, it's going. Don't alter the linkage of the list, okay, the items in the list. You can modify the items in there, but don't remove or add items in the middle of the for each loop, right? Breaks it. All right, a few more. You guys were on a good streak there. Oh, I'll just go back to Paul's question, though. I do get the results in early July. So if you're technically not graduated from the course in early July and you do get a 5, yeah, we'll count that really well towards your grade. Okay, let's see here. Oh, I lost my chat window. I don't know why this keeps popping up. Interesting fun fact. Neural networks. Oh, okay, look at this. 5. Oh, what is aliasing? Okay, this has never been asked on the AP exam, but we can give you a little. It sort of goes in line with some of the stuff we are just doing here. So in the previous questions when we were doing stuff like, I'll do this example here. Student Atom. I know this isn't going to work, but pretend the red lines aren't there. Exchange student gen I'm actually, the aliasing definition I'll give it. So if I do that, actually, you know what? Let's not do this. Let's just do this. Equals, there, that's easier. Okay, in memory, we've made one student. Adam points to it, and Jen points to it, right? Because Jen is set to point to the same address in memory as Adam. Okay, this is basically aliasing. So you got the two things. And they both point to the same spot. Now, what happens, just let me, okay. In compile time, let's assume that exchange student extends off a student. So student Adam is a new student, let's say that's fine. Exchange student Jen can point to that object, that's totally fine, it's a student. Well, let's do this the other way around, because that's not fine what I just did there. Let's do this. There we go. That's the acceptable one. Okay, exchange student is a new exchange student. Sorry, this one I'm not doing this one very well here. Okay, so we have this. Exchange student Adam is an exchange student memory. And then I say student Jen, point to Adam. Now, just to review the rules, Adam points in a spot to memory that has the code for students and exchange student, right? Exchange student builds off of student. So when I say, hey Jen, you're a student, it can only be set to point to something that refers to something that is a student or better. That's that Java is a rule, right? Is Adam a student? Yes, so Jen can point to Adam. Adam is an exchange student. Adam is also a student. So this is okay. So what you get is you get two variables, Jen and Adam, separate reference variables, both point to that one object in memory. When you actually go later on to do like, how does Java handle the aliasing? So let's say you go Adam.study. You're going to ask, which method does it use? Well, in memory, Adam is pointing to an exchange student. So the code for exchange student, however exchange student has study coded, which may be its own way, or it may be they didn't code it, they got it from student, but that's the way it's going to run. When you go, hey, Jen.study, it doesn't necessarily use the student study method. If exchange student has overridden and coded their own study method, then sitting there in memory at that location is an exchange student with their own exchange student study method. Jen will run the code for exchange student, right? Because that's the code that's there. Okay, it's been overridden. Okay, it doesn't run the study method necessarily that's in the student class. And that's just the rules of how Java handles it. Okay, some languages may do it different. Some languages may say, no, Jen is declared a student. It's going to run whatever the study method in student is. Okay, Java does not do that. It's whatever's in the memory address that's being referred to. Okay, and that is tested on the exam almost every year. They do something with the constructor and an overridden method, and they do something like this, and they go, what's the output, right? So definitely know that. An example of a method with return values. Get out of here. You know what that is. Now you put return values. We all know a method can only return one value, right? So methods can only return one thing, right? So if there's my method, you know, I can return one thing. When you do want to return more than one thing, a lot of students, if you want to return a lot of numbers, then return an integer array, right? And send back an array of numbers. If you want to return a lot of objects, maybe you return an array list of student, right? So you get a whole list of students back. What could be in the student class? Any info you want. Let's say you had some game data. Maybe you return a game data object. In game data, that class could have the variable, players, deaths, number of games, game. It could have tons of stuff in it. So you get to return one thing, but the one thing you return might have a lot of information encapsulated inside of it. Do you get points off for not writing efficient code? No. The only time in the no. So the answer is just no. Um, Honestly, I'm not sure if you wrote like 200 lines just to be that student to test them out. I wouldn't bother. But definitely, I've seen kids do stuff where they take 40 lines on their written when the answer could have been done in 3, 4 lines. Because maybe they said, oh, if I just would have sorted it first with like a bubble sort or something, oh, that would have made it so much easier. And they've gone and done some really weird methods. But no, they just want to know you can use the code you've been taught in the course and solve the problems, right? Do you know how to use your basic pieces to accomplish a task? The only questions you've got to be careful is the ones where it will say in part B and C, it'll say use your answer in part A for full marks in part B. Or it'll specifically say do not rewrite the code from part A in your answer to part B. Use the method name. So they want to know, do you know how to use a method in the class, in another method in the class, right? And if you go through the written exam questions, you'll definitely, they don't all do that, but you'll definitely come across some that do that. You'll know what I mean. How often do recursive methods utilize loops? No idea. Um, in most, yeah, no idea. I really think it would depend on what people are coding. That'd be a good one to ask on Stack Overflow. I think you'll get the same answer though. It'll be like, depends what you're coding, how complex it is. In all honesty, they teach recursion in the course, but you're going to hear a lot of people say recursion is bad for memory use because every time you go into recursion, you still have to remember that level of recursion has to be held in memory. So if you're going, let's say, 500, if you're doing a solve a chess program by recursion, you have to go like hundreds of thousands of steps into recursion. All those previous steps have to be remembered because when you come out of recursion, right, you got to come back out. So it's very bad memory wise. Like when you look at some of the sorts that are recursive, you can still like merge sort. The course codes it recursively, but you can just go Google merge sort without recursion and you're going to see them just using a for loop on it. And it's much more memory efficient. The recursive idea is just to introduce students to the idea that some problems can be resolved or solved by recursiveness, right? Like do the same task in a slightly different way, repeat that and you solve a problem, right? So it wasn't really a huge part of the course. Just know how to read some simple recursive methods. The one catch you should know on the recursive methods is this idea, and we did this quite a bit with my class, but it's the idea that when you have a method, is that when I call the method stuff, if I pass an x and let's say the variable was, integer num is 1, and then I go stuff num, system out num. I mean, everybody here should know this is going to print out. You type it in the chat box. There's only like 10 of you in the room. What's that going to print out? Num is 1. I call the method stuff. I print out num again. Somebody has to answer in the chat window before I tell you. There we go, Rishi. You got your 5. Okay, it stays 1, right? This is the idea that when arguments go in, they're copies. They're always copies. So if you send in primitive types, little int, little double, right? Little boolean, whatever you do to it, the change is not permanent, right? The method's making a copy. But when you send in, or strings count too, is primitives in this case, right? Because they're immutable. But when you send in arrays, objects, students, lists, they are changed. So if you do something to it, it is changed permanently, right? That's another rule that probably every second year, a question on that will pop up in the exam. And so sometimes they're very sneaky on the exam. They'll do a recursive method, and the recursive method calls another method like this. And of course, it suckers the students. They're so focused on the recursion, they forget what the question's really testing is. Are you noticing that it doesn't matter that that method's called at all? That method does nothing, right? It's irrelevant, really. So, you know, just, I don't know. Who knows? Maybe it pops up this year. It's been like a year or two since a question like that popped up. Runtime and compile time. Yeah, I mean, I can give you a list for the AP exam. Here are the only ones you're going to probably encounter. Okay, compile time. The compiler checks for rules. Okay, broken. These rules include like inheritance, polymorphism, ISA kind of rules. So example, if you try to say, like we said before, right? If you said exchange, I'm going to give you some more errors too, though. Exchange student E equals a new student. This will be a compile time error. The compiler says to itself, this variable type E is an exchange student. So whatever it refers to, right, whatever you set it to, has to be an exchange student or more. A student is not an exchange student, right? It doesn't have the methods. Exchange student has a couple extra methods. So the compiler detects that rule, okay? So that's a compile time error. If you did something like this, if you did have the student, so you had like student S, whatever you make it, and you said like s.study, the compiler is very like robotic. I mean, it is a computer program. It goes S. Oh, okay, S is a student. Okay, so it's really saying student. Can a student study? It checks the class. If it can study, good. It doesn't care how it studies. It doesn't care if the method's been overridden. Okay, that doesn't matter. All it wants to know is, can a student object study? Right? So it reads the class and goes, yeah, it can study. All's good. Right? So that wouldn't be an error. The compiler, public, private variables, right? If you try saying, hey, print out the student's secret code, and secret code is a private variable, that's a rule you've broken, right? So the is a rule. So that's access modifiers, right? Public, private. I don't think protected is on the exam, but whatever, it's there. So private, public, also checked. I mean, anybody that's been coding anything in the course, you've created your errors, right? Here are the common ones that are not the compile time errors. These are the runtime errors. Okay? So runtime errors. The typical one, right? Every student's done this one. Array out of bounds. Okay? Divide by 0. Don't do that on the exam, by the way. If you're summing some numbers and trying to get an average, and it's possible that the bottom number could be a 0, like they don't guarantee you that there's, the total is not 0, be careful you don't divide by 0. Put an if statement. If the bottom number isn't a 0, then do your calculation. Otherwise, return, sorry, can't calculate. Something like that, right? Dividing by 0, array out of bounds. The other one, that's a runtime error that it doesn't know, is bad casting, which they call casting. What do they call it? They call it whatever. I'll just call it casting error. I forget the actual word that NetBeans uses. Casting error. So if you tried doing something like this, so if you had student S is a new exchange student, okay, in memory. And let's say something that an exchange student can travel and a student can't travel, right? Like travel home. And you try doing this, travel home. First thing the compiler does, S, what is it? It's a student. Can a student travel home? No. The compiler, that would be a compile time error. So to fix it, a student might do this. Let's cast the student into an exchange student. And then we're going to ask that student, exchange student, to travel home. The compiler looks at this way. S is an exchange student. Can an exchange student travel home? Yes. So this is compiler fine. When the program goes to run and it actually attempts the cast while the program's running, it depends what's in memory. If S can be turned into an exchange student, all's good. But if this was the case, this is not good. In memory, there's a student. A student cannot be magically turned into an exchange student. It's lacking code, right? The exchange student extends off of it, has extra methods. So this would compile fine because the compiler just says exchange student can travel home. But when you go to run this, this will be a class casting error. You cannot cast it. This will give you the red lines of death and your program stops. There you go. Class cast exception. That's the error. Too much talking class. So you can't just cast in it. You can't cast an apple into a car, right? You can only cast things into things where in memory the code is there to qualify. Composition, they may use the word in a multiple choice. You know, like the whole idea of composition is like, you know, the extending the classes, right? Like class B extends class A. Like, how do you compose a class? Do you write it entirely or do you extend off another class? You can go look up like a Stack Overflow definition for that, or just go key in the Barron's, like the official definition. I'm always bad with the official definition on that one. But yeah, it's one of the words you should probably know, but it's you're not going to have to write about the definitions. All right, we only have a few more minutes left tonight. I do not have any tutorials on Git repositories. I will tell you though, students that have taken, the hour or whatever to learn about GitHub and stuff, they've enjoyed using it in the past, sharing files and the projects, and just a neat idea, right? How it's set up for programmers, build and test and everything. So it's definitely a nice little subtopic. And if you're going to university to study this stuff, then definitely one, put on your list of things you should learn about. No, yeah, for this course, what you find is you actually find that most teachers really struggle in the high school year and in the university year. Like here's what students have said that have gone on to like Waterloo and even like Oxford and Harvard and Princeton, and when they write back and they tell me about their computer science courses and stuff, they always say the same thing. They say AP Computer Science was great to take. They said their first year computer science course was so much easier. Like they basically knew everything. maybe up until the point of like the linked lists and stuff, right? You know, the tail end of the year. But definitely the first course, they're like, yeah, I was helping everybody. People didn't know how to do it, et cetera, right? Um, but most teachers at high school level and the university, they have a hard time getting through every single item listed in the AP course uh, topic list. You'll have a lot of high school teachers, especially, going, I've run out of time. Which topics shouldn't I do? And they'll always say, don't do merge sort. At most, it'll be one question, right? Stuff like that. Um, it's and it is a trade-off, right? Like I get through all the material, but we never have tons of time to do a lot of projects. I'd rather have a 2-year course with a lot of projects and go half the speed, yet have a lot of things being made. But just the way our school's set up with AP, the kids go AP nuts. They don't have the room in the schedule for 2 years of computer science, so we just do it 1 year. The professors at university, you'll often find if you took the first term course, they won't even cover everything in the AP course. What they're going to do is they'll pick and choose, and it doesn't matter to them whether they follow it or not because they're not trying to get credit for the AP course. So if you take AP Physics, very few first-year physics courses cover everything in AP Physics or AP Chemistry or AP Biology. You definitely learn more in your high school AP courses than you will in your first-year university courses of the same course. Um, Obviously, I don't want to do an absolute statement on that, but almost every student comes back. They agree. We learn more stuff, right? And whether it's physics, computer science, biology, chemistry, they learn. I used to teach AP Physics. The physics you definitely learn more, right? The professors at university skimp on certain topics, right? Because they can. Better review book than Barron's. I'll tell you. Everybody says how great the Barron's book is. I'm not a big fan. Here's what I think about Barron's. I think 50% of the questions are pretty good. And then I think somebody on the imagination train ran out of good questions, and they put some questions in there that are just weird and way uh, too hard, or as you look at them from a teacher's perspective, going, what are you really trying to check there? They're they're not checking anything of like super importance, and they're a little confusing. And then they make the kids worry, like, oh my God, I don't know this. What are they gonna? They're gonna ask me something like that. I think the Barron's questions overall are harder than the AP exam questions. That being said, it's a good thing in a way because it makes the kids talk and at least discuss, the questions. I think they do have some good questions. I think the overall review is good, like the chapter reviews, just going topic by topic. They do a good job at summarizing. I like the Princeton book. I think the Princeton book was actually a little better. All the review books have the same problem. If you go through every question, you're not going to say for all the questions, great question, great question, great question. Some of them you go, that's just filler. Like you're just making the kid read the code there. It's not really testing a like a hardcore or tricky concept. It's just like, you're just making him read the code and prick the output, right? Whereas they all have some good questions and they all have some bad ones. So really, it's use all the review books you can and use all the review. Yeah, you know what I mean. Use all the review books you can, and skip the questions that just seem weird. If you think they're weird, they're probably weird. Uh, the for each loop with a 2D array, I'll be honest with you, never done it. So I'm thinking that the first, it's going to sort of be like the dot length and the dot length. I could test it out here, but I'll let you test it out what happens. But I would think that the first for each loop is going to be running through the first set of square brackets, right? Or sorry, yeah, the first for each loop is going to be pulling out. There, let me actually type this out. If you add something like this, and I mean now it's been 2 hours, I may get lost in my own thoughts here, but the first for each loop. So if you just say, hey, go through, pull out a nums, what you're going to be pulling out of nums is you're going to be pulling out num0. And what's num0? Num0, and then it's going to pull out nums1, then it's going to pull out nums2, then it's going to pull out nums3. And when you pull that out, what are you getting out? You're getting out an array that has a length of 15. So the iterator is iterating through that, right, in the for each loop. And everything you pull out is an integer array of size 15. Now, you can send me an email if you show me code, prove me wrong on that one. I could be wrong on that one, but pretty sure that's how it ended up working. Yeah, the basic for each loop, it like I said, it's an iterator, right? Like if your array was only nums integer 5, you're going through slot 0, 1, 2, 3, 4. That's the for each loop, right? So if you have an extra dimension, then what you're pulling out is an array. Check it out though with some code. I wouldn't worry about the for each loop too much for those listening. You have to be able to read it. They'll use it in their problems for sure, just to usually loop through an array list. They're not going to ask you to write it. Okay, you can use it if you want, or you can use your regular for loop, right? It's up to you. All right. Other burning questions here? I think we'll probably end it like in a minute or two, unless you have a little last minute one or two. I'll probably go for, I don't know if the night before the exam or 2 nights before the exam. I know there's calculus the same day. Almost everybody's taking the calculus and taking the computer science, right? That's going to be a great day for you. I'm not sure where the physics is. That's usually the trifecta of cramming for people, doing physics, calculus, and computer science within 2 days. But at least it prepares you for university. In university, you could have like your 5 final exams. Um, you could have your 5 final exams all within like 3 days, 4 days. So the best advice for you going to university or college and doing this, if you're actually serious about doing well, like getting in the 90s, then cramming doesn't work so well. Treat almost every day as if the exam is the next day. Review a little every day. Then when exam time comes, you know everything really well, and there's seriously no stress. Some of you will figure this out your first year. Some of you won't figure this out ever. Some of you might figure it out in your 4th year. But when you figure it out, you're going to figure it out, and your university life will be much easier. Study the whole way along the way, and it's amazing. The grades. My 2nd year when I turned 19, and of course there were a lot of parties in the bar and everything like that. I did not follow that rule, and there was a definite decrease in grades. When I got back on track again the 3rd, 4th year, bam, like all back up, super high grades again, right? And it really doesn't seem like that much work either, and way less stressful. No 3D arrays. Almost for sure though, the 2D arrays. The 2D arrays have been like, geez, they've been on like, since they introduced them, I think they've been on almost every written question. At least one question per exam, right? Has matrices in it. But you guys know that because you've been going through the problems, right? Do not underestimate going through all the written problems. You don't necessarily have to sit there and code all of them, but definitely go through and read them and look at the tasks. That when you see a task that's easy, skip it, right? Don't do the easy stuff. It's the ones you want to look at and go, whoa, I don't understand this one. That's the one you want to take 10, 15, 20 minutes and try to read it and solve it and go check the answers, right? All the answers are up there online and in my folders. All right, I think we'll end it there. This file, it's like a 2 hour long file, but this file will be up on the website if you want to somehow navigate and pop between sections, right? It'll be up there on the site. So have a good night, guys. You got a good week and a half till the exam, right? You got lots of time. Go study your stuff, and of course, send me the questions on the site.